I have prepared a few past paper questions. These are from grade 11 final exam papers from different schools that I looked at, and we are just going to be working through these. Now, for the first question, they have told us that the graphs of f of x, which is 3 sine px, so I'm just on my graph going to go over that in blue. Sorry that it's a bit shaky. All right, so that is the graph of f that we are looking at. There we go. And then they're telling us that g of x is 2 sine x. So g of x is g. We can see that they've labeled it as g with a little g there next to the graph. Oops, there we go. All right, so we know that we are looking at these two graphs and they have been drawn for where x is between 0 and 360 degrees. Okay, so for 9.1, they're asking us to write down the value of p. Now, if we're looking at where p is in this equation, p is the coefficient of x. Now, what the number does, if there is a number in front of x that's not just 1, because if we're looking here for the graph of g, there is a number in front of x, but it's actually just 1, right? So here, where we have another number, which is not 1, then this changes the period of the graph. So changes period. Now, what happens to the period of a sine graph specifically? We know that the normal period of a sine graph is 360 degrees, but now because the number in front of x is labeled as p, we will have to divide that normal period by p to get the actual period that we're working with. Now, when we are looking at this blue graph, an indication of the period is the time that it takes, the x distance that it takes for this graph to complete one whole curve, one full sine curve. And we can see that we start at 0, go up to 3 in this case. Sorry, let me make that a bit clearer. Go up to 3, back to 0, then down to -3, and then back to 0. That is one full sine curve. So that means that the period of this graph is from 0 to 180 degrees is 180 degrees. So that means that we have that 360 divided by whatever that p value is supposed to give us 180. Now 360 divided by what is equal to 180? Oh, sorry about that. Let me just move that. 360 divided by 2 will give us 180 degrees. So the value of p in this case is 2. You can see that it's a 1-mark question, so you don't actually have to show working in order to get to that answer. You can just write that p is equal to 2. You can also view it as, normally we have one full sine curve from 0 to 360 degrees. In this case, we have two full sine curves. We have one there, and then we have another one there from 0 to 360. So if there are two full sine curves in 360, then the coefficient of x is going to be 2. All right, I just want to erase this so that we don't have too much going on here. All right, next question. What is the amplitude of f? Now, the amplitude of a graph is always the maximum point, maximum y value, minus the minimum y value, and then divided by 2. That will give us the amplitude of the graph. We need to remember that amplitude is always positive. So let me actually highlight that. So amplitude, oops, amplitude is always positive. You can never get a negative amplitude because the amplitude is the distance, okay? So when we're looking at the graph of f, then our maximum value is 3, our minimum value is -3. So if we want to use this formula, we can say 3 minus -3 divided by 2. Now 3 minus -3 is actually 3 plus 3, so this is going to give us an answer of 6 over 2, which is then equal to 3. That is the amplitude. You don't have to use the formula though. The formula is useful in cases where you can't actually see what the amplitude is just by looking at the graph. Or you can just look at the graph and say, what is the distance between 0 and my maximum value? 3. Or what is the distance between 0 and my minimum value, also 3, so that is my amplitude. The only time when that method won't work is when your graph has shifted up or down. So if your graph was starting at 1, for example, and went up to 4, right, and then went back to 1 at 90, sorry, this is not a very good looking graph, and then went down to -2 at the next point, like that. So essentially, if this graph just shifted 1 unit up, then you would look at the distance between 1 and your maximum value, and the distance between 1 and your minimum value, and it would still give you a distance of 3 units. Because the amplitude can be seen as the distance between your middle value and your maximum value, or the distance between your middle value and the minimum value. All right, so you can also just look at the graph and write down what the amplitude is. Okay, so those were both 1-mark questions. Those are both classified as knowledge questions, so they form part of the easier section of the paper. Now, 9.3, the general solution to the equation 3 sine px. Now, where's that 3 sine px coming from? That is actually the equation of our blue graph, is 3 sine px, equal to 2 sine x. That is the equation of our pink graph. Now, if we are making two graphs equal to each other, we are finding the points of intersection. So when they have written here that 3 sine px is equal to 2 sine x, they are talking about finding the points of intersection. Now on our graph, I'm going to use a different color now because there's a lot of blue going on. Let's use green. On this graph, we have one point of intersection there at A, so that's where the two graphs are equal to each other. We actually have one over there as well at 0. Then we have one at 180. And we have another one at B, and then again at 360. So these 3 points, we can just read off the coordinates of those points. The coordinates of A and B, though, they haven't actually labeled, right? We don't know exactly what that x value is. We can see that it is somewhere between 60 and 90. And for B, we can see that this value is somewhere between 270 and 300, but we don't know exactly where those values are, what those x values are. So now what they've done is they have given us the general solution to this equation, so for finding the points of intersection, and they have told us that the general solution is given as x equals k180. This is the same as 0 plus k180, right? So that will give us 0. So that point, it will give us, if we're saying 0 plus 180, it will give us 180. And if we're saying 0 plus 2 times 180, it will give us 360. All right, so this one general solution covers those 3 points that we could just read off of our graph. The next general solution is x is equal to 70.5 plus k times 360. Now, guys, this is where 70.5 is going to be, right? 70.5 is between, let me quickly make this a bit thinner, is between 60 and 90, and it is closer to 60 than it is to 90. So this is where we have 70.5. Right, so that is the x value of that point. I'm getting that, I'm getting that from this general solution down here. Now, the next general solution that they've given us is that x is 289,5 degrees. Now, 289,5 is between 270 and 300, but closer to 300 than it is to 270. So this is going to be 289,5 degrees, and I'm getting that from this general solution. So now they're asking us for this question to write down the x coordinates of the points A and B. So they've essentially given us those x coordinates by giving us the general solutions with these two values in. All right, so the x coordinate of A is 70,5 degrees, and the x coordinate of B is 289,5 degrees. All right, so if you understand what's going on, if you understand what it means when you make two equations equal to each other, is that you're finding the points of intersection, and you are able to identify those points of intersection and then figure out based on the general solutions that these are the values, the x values of those points of intersection, then this is not actually a difficult question. But if you don't understand all of those little bits and pieces, then it is going to be difficult to make those links. All right, now 9.4. For which values of x is g of x greater than f of x if x is an element of 180 to 360? Now that means that we are only looking at this section of the graph. Wait, let me make that a bit straighter. We are only looking, so much better. We're only looking at that section of the graph. We are completely ignoring the part between 0 and 180. They told us between 180 and 360. All right, so for which values of x is g of x greater than f of x? So now I'm going to take a different color highlighter. Let's do this kind of dark green. I am now going to highlight where the graph of g, which is the pink graph, is above the graph of f, which is the blue graph. Remember, in this section that we've just blocked off. Now, to my knowledge, it's going to be for that section there. We can see that for that bit, from 289,5 to 360 degrees, that is where the pink graph lies higher than, is above the blue graph. Okay, so we are going to say x is an element of, now I'll show you multiple ways of writing this answer. I can't include that point. I can't actually include 289,5 degrees because at that point the two graphs are equal. And they did not put an equal little line under our greater than symbol. So we are not including that value. So we're just going to say 289,5 with a round bracket in front of it to show that it's excluded. And then again, also 360, also with a round bracket, because at 360 degrees, those two graphs are also equal to each other. So again, we can't include that value. All right, so those two values not included. Or if you prefer, you can write this in interval or inequality notation. Sorry, this is interval notation. The notation where you use the brackets, where you say xe, which is for element of. So x is an element of, and then you have your round bracket if it's excluded and a square bracket if the value is included. Or you can write it in inequality notation. Sorry, I keep making that mistake. So 289,5 degrees and then smaller than x smaller than 360. That is inequality notation. You can decide which notation you prefer. Both will get you the same amount of marks. Both are correct. All right. This again is worth 2 marks, so I am sure that you will get 1 mark for each of your values there. Sometimes they give a mark for the values and a mark for the symbols or for using the correct brackets. So 2 marks like that. Just depends on what is on the memo. I haven't looked at the memo, so I'm not entirely sure. For the previous question, I didn't put the mark allocation in. It was also 2 marks. It would obviously just be 1 mark for each x value from there. All right, now next question, 9.5. They are telling us, or asking us rather, to write down the equation of h. Now, h is not a graph that we have. H is a different graph. In the form, h of x is equal to a sine bx minus c if h of x is f of x minus 30. Now, I'm just going to rewrite again what f of x was. F of x was 3 sine 2x. They told us in the beginning of this question that it is 3 sine px, but remember we then went on to calculate that p was equal to 2. All right, so 3 sine 2x. Now they want us to write down the equation of h. If h is 3 sine 2, but then instead of x, you're going to replace that with an x minus 30. That is what they're saying. H of x is f of x minus 30. So that means that in the equation, wherever we see x, we have to replace that with an x minus 30. So we're going to have the same a value, the same amplitude, sine 2, and then instead of x, we're going to write x minus 30 degrees. But now, look at this, the form that they told us to write this answer in. we can't have a number in front of this bracket. We're going to have to multiply that number into the bracket. So this 2 must be multiplied by the x and by the negative 30. So we're going to have 3 sine 2x, oops, I must put my brackets there, minus 60 degrees. Guys, that is important. You have to put brackets around the 2x minus 60. Otherwise, you're going to have this 3 sine 2x. And then completely separate from that minus 60 degrees. Okay, that is one term and that is a completely separate term. So you have to put the 2x minus 60 in brackets. All right, again, 2 marks. 1 mark for subbing in the x minus 30 and then 1 mark for multiplying that 2 into the brackets. Okay, so all in all, this was an 8-mark question. This is, like I said, from a past paper, from a very highly regarded high school that is in my area. So yeah, 8 marks is not that many marks in a paper out of 100 for trig graphs, but that is about what you can expect in a grade 11 final exam. It's about 10-ish marks, like 8 to 12, 13-ish, I would say.